Okay, I'm going to talk a little more detail now about 15 and problems like this, okay? The tricky part of this standard is not so much understanding sequences, okay? We did that worksheet about the Fibonacci sequence, or finding the different patterns in the numbers, and a lot of you guys are pretty good at that, okay? And once you recognize that pattern of numbers, all right, then you can determine what the next number is, or what the next number is, and you kind of make a prediction about what's going to happen going forward. Unfortunately, sometimes you want to go so far forward in a sequence that it would take you a long time to figure out, okay, well, what's going to happen after 50 terms, 100 terms, 200 terms. So unless you have a rule written for that sequence, it's going to be hard to figure out what you have after so many terms. Okay? And that sort of thing is really beneficial. And we'll work a little bit with savings accounts. Mortgages, how much you still have to pay can be figured out using sequences or patterns of numbers. Okay? The population potentially of fish in some lake could be used by these patterns of numbers. Okay? Yeah, maybe they lose 20% of the fish each year, but then they add, you know, a few hundred each year just to make sure they're keeping the population steady. All right. All these different patterns of numbers that get repeated over and over again can help you make predictions about what's going to happen going forward in the future. So the important thing is, can you write a rule to represent the pattern? Once you have the rule, life is easy. Okay? Once you have the rule, it's very simple. So anyway, number 15. It gave us this sequence of numbers, 1, 6, 11, 16, and so on. Okay? We noticed the pattern was adding 5 over and over and over again. And I talked about that. If you add the same number over and over and over again, it's kind of like you're increasing at the same rate. So in other words, the slope is staying the same. All right? The slope here is the same as the slope here is the same as the slope here. Everywhere on this line, the slope is whatever it is. Okay? So it's a consistent rate of change. You're adding the same number every time, even if you're adding a negative number every time. All right? That's still a consistent rate of change. Okay? So when you see a pattern of numbers where they're adding the same number over and over and over and over again, okay, first of all, it's called an arithmetic sequence. All right? An arithmetic sequence is when you are adding the same number over and over and over again. And if it was subtracting, you're still actually adding, right? Because subtracting is really adding what? Negative numbers, okay? So anytime you're adding the same number over and over and over again, we call it an arithmetic sequence. And I like to think of it as a linear equation. Because anytime you're adding the same thing over and over again, your rate of change stays the same. You're just really talking about the slope of a line. Okay, whether it's a positive slope or a negative slope. Okay? So an arithmetic sequence is really just a linear equation. It's a consistent rate of change. You're adding the same number over and over and over again. Yeah. Now, writing that rule was kind of difficult. Okay, we had a few tries that weren't correct. I'm going to give you a rule that will work every time for an arithmetic sequence. So if you struggle writing rules, which can be tricky, this is something you can use if you would like to, anytime you have an arithmetic sequence, meaning the pattern is adding the same number over and over and over again. Okay? To write an arithmetic sequence, all you have to do is take the first term plus the difference n minus 1 times. Okay? That represents the first term, that represents the difference, or the number that you're adding over and over and over again. Okay? So for this one, we'd have a sub n equals, what was my first term? 1. What's the common difference, the number we're adding over and over again? 5 times n minus 1, right? I'll distribute, so 1 plus 5n minus 5. I distribute to 5. and then I get 5n minus 4, right? And there's our rule. Okay, just like you guys kind of came up with.
And that will work every time.
For an arithmetic sequence, this will work every single time. Now let me explain why it works, because sometimes memorizing it can be difficult, like, well, is it n plus 1, where do I put the difference? You know, sometimes it's confusing. But maybe if I explain why it works, you might remember it a little bit easier, okay? So in an arithmetic sequence, we kind of start with that first number, right? Okay? So that's kind of where this comes from, a sub 1, the first number, okay? Now, to get to the second term from the first term, how many times would you have to add the difference? Once. So to get to the second term, I just had to add the difference, the 5, one time, right? To get to the third term, how many times would I have to add the difference? Twice, right? Plus 5, plus 5. To get to the fourth term, how many times would I add the difference? 3 times. To get to the 100th term, how many times would I have to add the difference? 99.